All right, so again, 7 and 8. This is where it says find the measure of the indicated angle. If you are trying to find an angle, that's when you use inverse. But the problem is, not the problem, the thing about that is it doesn't matter at first. At first, you set it up just the same as you would on number 5 or number 6. So first thing I do is I got to figure out which sides I'm working with. So here's the hypotenuse, and here's the adjacent. Remember, the angle is made from the hypotenuse and the adjacent. Those are the two sides of the angle. Then the one I haven't addressed is the opposite. So this one deals with opposite and adjacent, which is tangent. Opposite and adjacent, SOHCAHTOA. O and A is tangent. Okay, so tan of angle I don't know equals opposite over adjacent. This is the only time that you don't cross multiply is when you don't know the angle. You have to get the tan away from the x. It moves to the other side by making it a what? Inverse tan. Tan with that little -1, inverse tan. This is when I go to my calculator, and this is when I press the second button. So I'm going to do second tan 7 over 16. So 7 divided by 16. And that gives me 23.629. It says go to the nearest degree. That means whole number. So 23.6 is 24 degrees. Questions on that one? Okay, number 8. Here's the angle. One side of it is the adjacent and one side is the hypotenuse. The hypotenuse is the one that's not labeled. The adjacent is the 7. That makes the 6 the opposite. So on this one also I'm using opposite and adjacent. That was just a coincidence. Opposite and adjacent means which? Tan. So tan of this angle I don't know equals the opposite over the adjacent. When I don't know the angle, I have to get the tan away from it by doing inverse tan. So inverse tan of 6 over 7 equals x. So I do second tan 6 over 7 is 6 divided by 7. And I get 40.6. Rounding that to the nearest degree means 41 degrees. Questions on either of those? Okay, that's the only time I press the second button is when I'm finding the angles. Now down here, this is where a lot of people lost most of their points. Okay, so let's just look at these. These are really important. Solving a right triangle means finding all the side lengths, all the angles. Okay, you already start out with 3. You know 62 degrees, 90 degrees, and 12. Okay, that leaves us with an angle you don't know and with 2 side lengths you don't know. Those are the 3 things I'm looking for. All right, the easiest one to find here is which, do you know? That angle. Because these 2 angles, remember, the 2 angles that are not 90 have to add up to 90. So I can subtract 62 excuse me, from 90 and get 28 degrees. So this is 28 degrees, just subtracting from 90. So that was one of your answers. Okay? Now, in terms of finding the missing side lengths, it really doesn't matter which one you find first. I would probably find, it really doesn't matter. I don't even know which one I would do. On any given day, I might do a different one. But you can only work with one missing side at a time, so you got to pick one. I'm going to find this one over here. I'm going to call that X. And then I'm going to figure out which sides I'm working with. This is hypotenuse. This is adjacent. So I'm going to be working with the hypotenuse and the adjacent, which is the what? Adjacent hypotenuse is cosine. Cosine of 62 degrees equals adjacent over hypotenuse. I'm not finding the angle, so I'm not using inverse. I'm cross multiplying. 12 times cosine 62 equals x. X is alone, so I'm ready for my calculator. 12 times cosine 62 should give me 5.6. So x equals 5.6. So now I've got this one, 5.6. What is the easiest way to find the last missing side of the triangle? Pythagorean theorem. Maybe. Some people might prefer to use maybe sine now. You could do opposite over hypotenuse. Sine of 62 equals opposite over hypotenuse. I would probably use Pythagorean theorem. Okay? Because I have 2 out of 3 sides. So be careful if you're going to use the Pythagorean theorem, though. You remember that 12 is the hypotenuse. So in other words, it goes 5.6 squared plus the side I don't know squared. Let's call it, I don't know, b, equals 12 squared. So 5.6 squared is 31.36 plus b squared, that's a b, not a 6, equals 144. Subtract 31.36 from both sides, and you get b squared equals 112.64. Always end the Pythagorean theorem with a square root, and that gives me 10.6. Now I know everything there is to know about this triangle. All 3 sides, all 3 angles, and those are all my answers. Yes, sir?
How did you get an angle?
I just subtracted 62 from 90 because the 2 acute angles in every right triangle have to add up to 90. Remember, all 3 of them add up to 180. So if we've already used 90 degrees out of our 180 here, that leaves me with 90 for these 2. Okay? Next one. This is the one where a lot of people tried to make this a 45, 45, 90. I think maybe just because it kind of looked symmetrical. But see, look, the 2 sides are not the same. It cannot be a 45, 45, 90 when the 2 legs are not the same. Okay? Easiest thing to find first here might be the 3rd leg. I could use the Pythagorean theorem, but I'm going to wait on that. I'm going to find one of the angles first. I'm going to start by finding angle A. So this becomes my x. So now I've got to figure out which sides I'm working with. Here's the hypotenuse. Here's the adjacent. Here's the opposite. So I'm working with the opposite and the adjacent. That's the what? Tan, actually. Tan of x equals opposite over adjacent. That means inverse tan, x equals the inverse tan of 19 over 22. So in my calculator, I do second tan 19 divided by 22, and I get 40.8. Okay, 40.8 rounds up to 41 degrees, and they've been telling me to use whole number degrees. So if this angle down here is 41 degrees, just like over here, I can subtract that from 90 to get this angle right here. 90 minus 41 gives me 49. So now I have both angles. The only thing left to find is the missing side, the hypotenuse. So I'm going to do Pythagorean theorem. 19 squared plus 22 squared equals hypotenuse squared. 19 squared is 361. 22 squared is 484. Add those up, and you get 845. Last thing I'm going to do is take the square root, and I get 29.06. Okay, it specifically said round side lengths to the nearest tenth. So 29.06, back up here, what I just underlined, is going to be 29.1. So here are my 3 answers for this one. Okay, I'm going to put some more practice of these types of problems up on eClass. If you can do this type of problem, then you can do, it's like it's a combination of everything you have to do. So you can do everything in this unit if you can do one of these. Okay, how much time have I got?
5 minutes.
Okay, good.